yes, CT can be useful if you know what you do with it. So a lot of companies deal with CT as the end product of their inspection. Here at Creative Electron, CT is the beginning of a long process that has to do with analysis, it has to do with computer vision, artificial intelligence, and ultimately a pass-fail decision on your samples. So to exemplify what I'm talking about, I picked up this sample. This is not really the sample from our customer because that's covered under a non-disclosure agreement, and the NDA doesn't allow us to just show what the product actually is that we did this for, but it's very similar. So this is a box of hypodermic needles, 100 needles inside this little box here. One option, if you're going to do 2D or 2.5D inspection to find if these needles are bent or in any way damaged would be to open the box and then look at one needle at a time, right? And you have to do an analysis in at least two different locations to find if these needles are bent or in any way damaged. Now, we didn't want to do that. We wanted to be able to look at all the needles inside the box at once. So what we did is we did a quick CT of this whole box and then isolated each needle from the CT volume, and then we ran each one of those needles through a computer vision program that calculated the bend of each one of the needles, and then based on that, we're able to pass or fail that specific needle. Then knowing where that needle was within the location inside the box, we can even at the next step open and remove the needle that's not passing quality control. Like I said before, CT is not the end, CT is the beginning of the inspection. So we start with CT, right? We don't end with CT, we start with CT. From the CT volume, we run a series of computer visions or AI algorithms that allow us to identify and then run isolated or run different algorithms on each one of the samples within this volume. And then based on that, we can generate pass, fail decisions that we can then run automation to then separate that specific sample from your production line or keep it for rework or everything else you might want to do. So this is a critical thing, right? When you think about CT, think of CT as the beginning of the quality process, not the end. So to show you how it looks like and how cool it is, let me show you some videos that show the computer tomography or the CT of this box of needles. As you can see in this video, there are all the needles rotating, and we're able to identify the defective needles within this stack, right? So we found the needle in a haystack, literally. And we were able to color them green, red, or blue, depending on the defect they have. So these other videos here that I'm going to show you identify, and we're able to separate based on the type of defect, the type of problem we have. So this is a bent on the middle of the needle, as you can see here. The bent is right in the middle. This other defect shows a bent on the base of the needle. And finally, the third defect that we're looking for is a bend on the tip of the needle, that you can see right there. Right? So all these different pass-fail determinations were determined by our quality control, and automatically our algorithm, in this case we didn't have to use AI, we're able to use computer vision, and what we did is by isolating each needle, we're able to cross-section it, right? Put it on a plane and then measure that angle of the bend. You want 0 degree angle most of the time, and if you have a degree of over 2 degrees in this case, we'll fail the needle as defective. Thanks so much for watching, and don't forget to subscribe.